A deep crimson light hangs above Earth every winter. To most people, it's just another star in the constellation Orion. But astronomers know it by another name. Betelgeuse. A giant so enormous that if it replaced our Sun, its outer atmosphere would stretch far beyond the orbit of Mars. For centuries, Betelgeuse has watched over humanity from the night sky. Ancient civilizations tracked its movements. Sailors used it to navigate. Generations looked upon its reddish glow and assumed it would always be there. But stars do not live forever. And Betelgeuse is dying. Not tomorrow. Not necessarily in our lifetime. But by cosmic standards, its final chapter has already begun. Now something unexpected has happened. A dramatic increase in brightness has captured the attention of astronomers around the world. New observations have revealed changes inside this colossal star that scientists are still struggling to fully explain. And once again, a question that has fascinated researchers for decades is being asked. Are we witnessing the early warning signs of one of the greatest explosions humanity will ever see? To understand why this matters, we first need to understand what Betelgeuse really is. Located approximately 640 light-years from Earth, Betelgeuse is one of the largest stars visible to the naked eye. Its size is almost beyond imagination. If our entire solar system were shrunk to fit inside a football stadium, Betelgeuse would still dominate the field. Yet despite its enormous scale, this giant is surprisingly unstable. Unlike our Sun, which quietly burns hydrogen in its core, Betelgeuse has already consumed much of its original fuel. Deep inside, multiple layers of nuclear fusion operate simultaneously. Hydrogen, helium, carbon, oxygen. Each layer producing energy in increasingly complex and unstable ways. Astronomers often compare the star's interior to an onion. Layer upon layer. Shell upon shell. Each one fighting against gravity's relentless pull. But gravity never stops. And eventually, gravity wins. This struggle creates a star that is constantly changing. Its surface swells. Its atmosphere contracts. Its brightness rises and falls. Immense rivers of superheated plasma surge across its exterior like storms larger than entire solar systems. To observers on Earth, these changes normally appear gradual. Predictable. Part of the star's natural behavior. But recent observations suggest something different may be occurring. Scientists have detected an unusually powerful increase in luminosity. Not a small fluctuation. Not a routine variation. But a surge significant enough to attract global attention. And whenever Betelgeuse behaves unexpectedly, one possibility immediately enters the conversation. Supernova. The word alone carries enormous weight. A supernova is the explosive death of a massive star. When a giant like Betelgeuse finally exhausts its ability to produce energy, its core can no longer resist gravity. The collapse happens in moments. Then comes the explosion. An event so powerful that for a brief period it can outshine billions of stars. If Betelgeuse were to explode, people across Earth would witness a sight unlike anything seen in modern history. A brilliant new object would suddenly appear in the sky. Visible during daylight. Bright enough to cast shadows at night. A cosmic beacon shining for weeks or even months. Fortunately, Earth would remain safe. Despite being relatively close in astronomical terms, Betelgeuse is far enough away that its explosion would pose no direct threat to life on our planet. Instead, humanity would receive a front-row seat to one of nature's most spectacular events. But before we start counting down to a supernova, there is an important problem. No one actually knows whether that's what we're seeing. Because there is another explanation. And it may be just as fascinating. Betelgeuse is not a calm star. It is a turbulent ocean of plasma. Its surface is covered by gigantic convective cells, regions where hot material rises from the interior while cooler material sinks back down. Imagine storms larger than the distance between Earth and the Sun. Now imagine thousands of them. When one of these colossal plumes reaches the surface, it can release extraordinary amounts of energy. The result can be a sudden increase in brightness that mimics something much more dramatic. In other words, Betelgeuse may not be approaching imminent destruction at all. It may simply be experiencing stellar weather on a scale that human beings can barely comprehend. And that possibility opens an entirely new mystery. Because if this is not the beginning of a supernova, then what exactly is happening inside the heart of this dying giant? The answer may be hidden beneath layers of plasma, magnetic fields, and nuclear reactions unlike anything found in our solar system. And what scientists discover next could completely change our understanding of how massive stars die. The mystery surrounding Betelgeuse did not begin with its recent brightening. In fact, astronomers have been watching this star with growing fascination for years. Because before Betelgeuse became brighter, it became dramatically darker. In late 2019, observers around the world noticed something extraordinary. The giant red star was fading. And not by a small amount. Its brightness dropped so dramatically that even amateur skywatchers could see the difference. Within months, Betelgeuse had lost more than half of its visible brightness. For a star already known to be nearing the end of its life, the timing was alarming. Almost immediately, speculation exploded. Had the countdown begun? Was Betelgeuse preparing to become a supernova? For a brief moment, some scientists wondered if humanity might be about to witness one of the greatest astronomical events in recorded history. News headlines spread across the globe. Social media filled with predictions. Astronomy forums erupted with debate. But the truth turned out to be stranger than many expected. After months of investigation, researchers discovered that Betelgeuse had likely ejected an enormous cloud of material from its surface. As this cloud cooled, it condensed into cosmic dust. That dust drifted between Earth and the star, partially blocking its light and creating the illusion that Betelgeuse itself was fading. The event became known as the Great Dimming. It was unlike anything previously observed from the star. And it revealed something important. Betelgeuse was far more dynamic than scientists had realized. The star wasn't simply sitting in space waiting to explode. It was actively reshaping itself. Constantly changing. Constantly evolving. And perhaps becoming increasingly unstable. Now, years later, astronomers are asking whether the recent brightening is connected to that dramatic dimming event. One possibility is that the dust cloud has gradually dispersed. As the veil clears, more of the star's light reaches Earth, making Betelgeuse appear brighter once again. But there may be more to the story. Deep inside the star, forces beyond human imagination are constantly at work. Immense currents of superheated plasma rise from the interior. Violent shock waves travel through its atmosphere. And hidden magnetic fields twist through the star like invisible tornadoes. These magnetic fields may hold one of the biggest clues. Unlike the magnetic field surrounding Earth, Betelgeuse's magnetic environment is chaotic and unstable. The star's enormous size creates turbulent flows of charged particles moving in every direction. As these flows interact, magnetic energy can build up over time. Eventually, that energy may be released suddenly. When magnetic structures reconnect or collapse, they can unleash enormous bursts of power. On our Sun, similar events produce solar flares. On Betelgeuse, the same process could occur on a scale almost impossible to comprehend. Some researchers believe these magnetic eruptions may explain rapid changes in brightness that traditional models struggle to predict. If true, the star's recent behavior may not be a sign of imminent death. Instead, it could be evidence of powerful magnetic processes we've never directly observed before. And that is what makes Betelgeuse so fascinating. Every new observation seems to answer one question while creating three more. Modern telescopes continue monitoring the star across multiple wavelengths. Visible light, infrared radiation, radio emissions. Each instrument reveals a different piece of the puzzle. Yet the complete picture remains frustratingly incomplete. Some data suggest growing instability. Other observations point toward normal behavior for a giant star nearing the end of its evolution. The result is a scientific mystery unfolding in real time. A star caught between predictability and chaos. Between life and death. Between what we understand and what remains unknown. And perhaps that uncertainty is the most important lesson of all. Human beings often imagine the universe as fixed and permanent. The stars appear unchanged from one generation to the next. They seem eternal. But Betelgeuse reminds us that the cosmos is alive with change. Even the brightest objects in the sky are temporary. Every star is part of a cycle. Stars are born from clouds of gas.